Welcome back, everybody. We're going to start Chapter 9. So in Chapter 8, we were doing a lot of exponents. Now we're going to apply that, and we're going to start to work with polynomials. So our first lesson is adding and subtracting polynomials. First of all, let's talk about what is a polynomial. Before we do that, we have to figure out what is a monomial. So a monomial is an expression that is a number, it's a variable, or the product of a number and a variable. Let me show you what I mean. Another name for a monomial is also called a term. So here's this 2. It's a number. That's a monomial. X, a monomial. I could put them together by multiplying. I could say 3x. That's a monomial. 2x to the fourth w, monomial. This is a monomial. This is a monomial. This is a monomial. Okay? Now, how do we do the degree of the monomial? The way we find a degree of a monomial is we identify the exponent on each variable, and that's really important. It's on the variable. It's not on the number. It's on the variable. And add the exponents if there are more than one variable. And the degree is the final numeric answer. What do I mean? So let's look down here. This monomial is negative 3x to the first. So I'm going to only focus on the x. The variable of x has an exponent 1. So that's all there is. This is a first degree. Okay? First degree monomial. Alright, on my next monomial, I have 7 multiplied to x squared y to the third. So I'm going to look at the exponent on the x and the y. So I have an exponent of 2 here, and I have an exponent of 3 here. So I do add them. So this is a fifth degree monomial. The last one is a constant. It has no variable, but remember, there is a variable. It's invisible, and it's right there. So this would be a 0 degree monomial. Okay, what is a polynomial? Well, a polynomial is a monomial, or the sum or difference of 2 or more monomials. So what does it mean? It means that this is a polynomial, and this is, and so are these. It's just that these have several monomials added together, and these have 2 monomials, and this is just one monomial. So they all are in the category of polynomial. Standard form of a polynomial is the degrees of the monomial terms decrease left to right. And I'll show you how to do that. And the degree of the polynomial is the highest degree in the list of monomials. And I'll show you how to do that. Let's start. What I'm going to do first is find out the degree of each of my monomials. So this is a first degree here, and this is a 0 degree here. Okay? So I take my highest degree. My highest degree was 1. Okay, so let's do this for all of them. This is a second degree, and this is a 1 degree, and this is a 0 degree. So my highest is 2. Here, my highest degree is just 3. So I'll write 3. Here, my highest degree is 4. And my other degree is 1. So my highest of between those is 4. Notice I'm taking the highest number, and this is a 0 degree. Okay? Now let's name them based on their degree. Well, please fill these in. First degree is linear, and think about this. Y equals 7x plus 4. We can graph that line. Second degree would be quadratic. Okay, that would be quadratic. Third degree would be cubic. Okay, that makes sense, cubing something. After the third degree, we just name name the polynomial based on its degree. So we'll say fourth degree. If it's a 0 degree, we call it a constant, and that's what we refer to a plane number anyway. We refer to it as a constant. Now I want to talk about how many terms are in the polynomial. Remember, a monomial is also called a term. This has 1, 2. So it has 2 terms. This has 1, 2, 3. So 3 terms. This is 1 term, this is 2, and this is 1. So we're going to name this polynomial, these polynomials, based on how many terms they have. And here it is. So 2, think of a bicycle, 2 wheels, binomial. 3 would be trinomial. And if there's just 1, it's a monomial. Okay? So please fill in this chart. We're going to put it all together here. So we're going to classify these polynomials. Write each polynomial in standard form. I'm going to show you what that is. And then name each polynomial based on its degree and the number of terms that are in it. So remember, standard form is the largest degree. Yep, so largest degree to smallest degree. So this is a degree of 1, and this is a degree of 0. So I'm going to write negative 2x. It's very important that I remember that there's a negative there, plus 5, commutative property. Let's do this one. Before I put it in standard notation, what I'm going to do is I'm going to combine like terms. So I'm going to take the 3x to the 4th and the 5x to the 4th, and I'm going to put them next to each other and add them together. So I end up with 8x to the 4th. And if you look, that's my largest exponent. That's a 2, that's a 0. So these two have been added together and they're right here. So next, my next largest is this one, 2x squared. And my next or last is this one. So biggest to smallest, 4th degree, 2nd degree, 0 degree. Now I'm going to do this one. I have a 2, a 0, and a 4. So let's put this one first. Here's what I came up with. Negative 9x to the 4th plus 6x to the 2nd plus 7. Okay, here I have a 1, a 0, and a 3. So this is first. So remember, I keep the negative sign. It belongs to the y to the third. And then this was second, and this is last. So the constant is always last. All right, let's combine like terms on this one. Combine like terms. I end up with 8 minus 4v because it's 7v minus 11v is this. So this will go first because it's first degree. So I'll write negative 4v plus 8 because it's positive. So I need to name them based on their degree and number of terms. But notice before you do that, you have to simplify. So don't, otherwise this B and E would have been misnamed. So what's my highest degree here is 1. Because my highest degree is 1, I'm going to call it linear. And because it has 2 terms, it's a binomial. So this is a linear binomial, 2 terms. All right, what's my highest degree here? 4. So this is how I write this one. This is the 4th degree. That's my highest degree. Trinomial, because there's 1, 2, 3 terms. If I would have done it before I simplified, it would have been a 4-term polynomial. And that's why it's very important to simplify first. So how about hit pause and try and do these on your own. So hit pause right now and try and do these. All right, we ended up with another 4th degree, biggest degree, trinomial, I abbreviated. This, the biggest degree is 3, so that's cubic trinomial, 1, 2, 3. This, the biggest degree is 1, so it's linear, and it's 2 terms, binomial, same as the first. All right, we're going to talk about adding polynomials. It's kind of like combining like terms, really. If we're adding this trinomial to this trinomial, one way is to add vertically. I'm going to show you how to do that right now. You basically line them up so like terms are on top of each other, kind of like what we did with elimination, and just add straight down. So here we go. 4x squared plus 2x squared is 6x squared. 6x minus 9, or plus negative 9x is negative 3x, and 7 plus 1 is 8. Let's do it horizontally. You need to here group like terms. Ignore the parentheses, okay, associative property, ignore the parentheses, and put all like terms together. Here's what that looks like. I tried to do these terms in blue and these terms in black, like I did here. Okay, just put these together. 4x squared plus 2x squared is 6x squared. And 6x plus negative 9x is negative 3x. And 7 plus 1 is 8. You get the same answer either way. Okay, what we're going to do is subtract polynomials. So, first, we're going to change the problem into addition by distributing the minus sign. Basically, keep, change, 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 change. You can do it this way by going keep, change, 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 change. And that's fine. Or you could line it up first. So now everything's changed. Now I'm going to write it as an addition problem. What I'm going to do is show you, I showed you how to change it here. You could also set it up like this and change it this way, and I'm going to do that. We do have to line up our like terms. This is very important. So my x cubed goes underneath here. X squared, x squared. Notice that this is missing a plain x. So what I need to do is say plus 0x. Okay? So now I'm going to do keep, change, 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 change. So here we go. So keep, change, 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 change. This won't matter because it's 0. All right, so let's add going down. Negative 2x to the third minus 1x to the third is just x to the third. 5x squared plus 8x squared is 13x squared. And negative 3x minus 0x is still negative 3x. And lastly, nothing, or 0, minus 11, or plus negative 11 rather, is just minus 11. There's my answer. So this is a cubic 4-term polynomial, and it's in standard form. Perfect. Another way to subtract is to do it horizontally. And here you're going to do keep, change, 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 keep, change, 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 change. And then what we're going to do is group our like terms, just like when we added horizontally. So this is what that looks like. So these terms I used in black, and these terms I used in red, and I made sure that this wasn't x to the third power. It was negative x to the third power because I had to change them, and that's not plus 11, it's minus 11. So just combine your like terms and you're done. Notice we have the same answer as we had before. All right, a couple of problems with shapes. So this is a pentagon, and we need to find the perimeter of the figure. So basically all we're doing is adding up all of the sides. Okay, so what I did was I took 2c plus 3, I wrote it here, and I just added all of these up. Now, technically, should I have parentheses on each of these? I suppose. But it's not needed because we're adding them all up, and now basically combine like terms. So let's put all the c's together. I put all the c's together. 2c plus 3c plus 5c plus 2c again. Next, I put all my constants together. 3 plus 1 minus 4 plus 7. So put it all together and you'll be done. My answer is 12c plus 7. This adds up to 12c, and this 3 plus 1 is 4, minus 4 is 0, plus 7. Done. On this example, we need to find the missing side length if we're given the perimeter. So the perimeter, so we know that it adds up to 13x plus 4. So what I'm going to do is try and find out what this adds up to find out what I'm missing over here. Okay, so I want to find out what this side length's worth. So first thing that I want to do is I want to add up all of the sides I know. Okay, so I'm going to write this out as an addition problem because perimeter means add up all the sides. So I wrote all of the monomials together and added them, and what I did was I combined my like terms, put my like terms together. So how many total x's do I have? I have 4x plus 3x plus 1x is 8x. So I have 8x. And what do I have for constants? I have negative 9 plus 2, so that's minus 7. Now, it's going to be kind of like working backwards kind of thing. Because what we're going to do is we're going to say, what do we have to add to this? Because this represents here, here, and here. What do we have to add to this to make it add up to this? So, what we can do is we can subtract these. So that's exactly what I'm going to do. I'm going to write 13x plus 4, and I'm going to minus 8x minus 7, this. Okay, so we're going to do keep, change, change, change. Change, change, change. Now I just add going down. 13x plus negative 8x is 5x, and 4 plus 7 is 11. So this missing side is 5x plus 11. That's my missing side. Okay, here are your practice problems, and bring any questions you have to class next time we meet. Take care.